Okay, so we finished step one in our program of finding methods to solve triangles. Remember, by solve triangles, I mean if I give you some of the triangle's dimensions, you find the missing pieces, right? You find all the others. We've covered the angle side angle and side angle angle case, and we were able to solve those definitively using the law of sines. Everything worked fine. Well, we're going to continue to use the law of sines here to talk about the side-side angle case, but this one has some issues, right? So here's the problem with this side-side angle situation, right? So let's be clear on what we know. I know this side length, I don't call it B, let's call it A. I know this side length, let's call it B, and I know this angle. Right now, this dashed line here, that one I don't know. That could be any length. And I also don't know this angle up here. That can be any angle. So the way I kind of think about solving this is, say you start with this side B up here, and you let it rotate down, let it pivot along that point. When it hits that line down there, that dashed line, you get a valid triangle. Right? You get a triangle that meets all of my requirements. Now, here's where we run into potential trouble with this scenario. If I let it continue to pivot, right? You see how it's turned around here. It's going to come back around and hit that dashed line again. Okay, so what I have here is two triangles. I have two triangles that meet all three of my requirements. Sometimes. Sometimes we are. We're going to have three cases that we have to be aware of, right? And I've got all three of them illustrated here. This is my case, the left-hand scenario. This is my case from the previous slide, where we have two solutions. It's possible that we get a perfect match, right? It's possible that this side, when I start doing my rotation thing, it's just tangent to this line, and I get exactly one solution. And over here, maybe that line is just too short, right? Maybe that side length is just too short, and I end up getting no solutions. Three cases that we're going to have to be aware of. Okay, so let's look at how these things play out. I've got a scenario here, right? A equals 2, C equals 1, and angle C is 50 degrees. So let me sketch that here. Again, I'm going to use a dashed line here for this side that I don't know. This side is going to be 2. This side is going to be 1. And this angle is 50 degrees. So this is C, and this is A. Yes. Okay, good. So, let's go to our law of sines, right? The law of sines, I'm going to do A and C. I really have to do A and C, right? I don't know angle B, and I don't know side B. I have to do at least one of a pair to use this law. So I'm going to do C first. So I'm going to say sine of 50 degrees over 1 equals the sine of A over 2, right? And let's see what happens then. I get the sine of A equals 2 times the sine of 50 degrees. And according to my calculator, 2 times the sine of 50 degrees is 1.5. Now we're in trouble. The sine of an angle cannot be 1.5. Sine of an angle can't be greater than 1. Okay, so what does this tell me? This is the no solution case. Right? If we get something like this where I get the sine of an angle equals a number that it cannot equal, then this triangle doesn't exist. Right? So I'm going to say no such triangle. Okay, so that's the zero solution case. Okay, how about this one? All right, well, let's see. I'm going to sketch it again. I have my dashed line here, my unknown side, and A is 35. This is going to be side C, so this is 4. And this side here, this is side A, so that's 6. So these two will be B, and this will be angle C. All right, so I'm going to follow the same program, right? I'm going to go after angle C first. So I'm going to say the sine of A over A equals the sine of C over C. And let's put some numbers in. Sine of 35 over 6 equals the sine of C over 4. And then let's see, multiply both sides by 4. The sine of C equals 4 sine 35 over 6, which according to my calculator is 0.382. Get a calculator, inverse sine of both sides. C is 22.48 degrees. Okay, let me make that should be a capital C, make that clear. Okay, so I'm gonna put that on my diagram. 22.48. All right, now let's go, because it's easy, let's go ahead and grab angle B. Angle B is 180 degrees minus 22.48 minus 35, and that is 122.52 degrees. Good, 122.52. Okay, good. Now, let's see. Let's go ahead and wrap this up. Let's find side B, and I'm going to use the law of sines to do that again. Sine of A, let me go back to the blue. Sine of A over A is sine of 112.52 over B. That should be in lowercase a. Excuse me, that shouldn't be an A. Sorry, I can't read my own writing. That's not a B, it's a 6. My B's and 6's are a little too close to each other. See if I can make them a little more different. Okay, so B is, what is A? Sorry, I know angle A. Put 35 in there. There you go. Mixing formula and numbers. Okay, so let's solve this for B. B is equal to 6 sine 122.52 divided by the sine of 35 degrees, which means B is, according to my calculator, 8.82. There you go. I have solved my triangle. But here's where I got to stop you. Okay. Sine of A equals 0.382. There's a second possibility for angle A, right? Think about your unit circle for a minute, right? I've got this angle A, and its sine is 0.382, so that's going to be here somewhere. Okay, but there's another angle. There's another angle over here that has that same sign, right? There's a second one. Okay, what is this angle? Well, that angle is 180 degrees minus 22.48, which is 157.52. Okay, so this is where I'm looking at this and saying, okay, maybe I have a second case I have to consider, right? This is where the second angle comes from. It comes from this reference angle business. Okay, now, the next thing you do once you've identified this, find the third angle. Okay, find the third angle. So let me, should have made my triangle bigger. My potential angle for B, excuse me, that was angle, yeah, that was angle B. Oops, sorry, that was C that came out to 22.48. So a second possibility for C is 157.52. Next thing you do immediately, try to find angle B. Right? Angle B would be 180 minus 35 minus 157.52. And if you do this, you get a negative number. Right? You get a negative angle for B. When we're talking about triangles, right, we're back to talking about physical objects. When we're talking about triangles, that's not possible. Okay? So this is how you identify a scenario where you have only one solution. Okay? So hopefully you're kind of building up this process in your head. When you have these side angle questions, first you just go through the process. You try to find the missing sides. If you get sine of an angle equals an impossible number, there's no solutions. If you get a solution, then your next step is to do this reference angle process, come up with a second possible value for the second angle, the first angle that you went out and found. Check to see if that's possible. Check to see if that gives you a valid third angle. If it doesn't, you're done. There's one solution, move on. If it does give you a valid angle, and we're going to do an example of this in the next slide. If it does give you a valid angle, then you just go through the whole process again with that second set of dimensions. All right, so we'll see how that works. Okay, so let's take a look at this third case. And I know I'm going to need a little room here because I'm going to have to do this twice. So I'm trying to look ahead. I'm going to put my diagram up here a little bit out of the way. So this is going to be A equals 2, C equals 3. Whoops, sorry, that got to be the other way around. This one, this is going to be my angle A. That's 35 degrees, which means side A has to be opposite it, and side C would be the other side. Then I'm going to do B and C, and we're trying to find B. Okay, so let's go through the process. Let's call this case 1. I'm going to do the sine of A over A equals the sine of C over C. That's, let's see, sine 35 divided by 2 equals the sine of C over 3. So the sine of C equals 3/2 sine of 35, which is 0.385, which means angle C, do the inverse sine of both sides, is 59.4 degrees. Okay, excellent. That's angle C. Let's find angle B. Angle B is 180 degrees minus 35 minus 59.4. That is 85.6, and that's a valid dimension, right? That's good. And now, finally, I'm going to find side B, right? I'm going to do sine 85.6 divided by B equals the sine of 35 divided by 2. And you solve this for B. B is 2 sine 85.6 divided by the sine of 35, which my calculator says is 3.47. Excellent. I got a perfectly good triangle out of this process. Okay, that's case 1. Let's draw a line here, right? Separate these two. Now let's do case 2. Okay, go back and look at that angle C, right? Angle C is 59.4 degrees, right? Do a quick sketch here of my unit circle. 59.4 degrees is here, which means this angle with a reference angle of 59.4 degrees has the same sign, right? Well, what is that angle? 180 minus 59.4 is 120.6. So I have a third possibility. Angle C is 120.6 degrees. Okay, now first thing we do, go after angle B, right? Make sure I get a valid result for angle B. B is 180 degrees minus 120.6 minus the original 35, and that comes out to 24.35, and that is a valid result, right? I do get a valid triangle out of this, right? So now what do? Now we go back to the law of sines and do it all again, right? I'm going to find, let's see, side B. That's the only missing part now, right? I know all three angles. I know side A and C. All that's left is to find side B. So I'm going to say the sine of B over B equals the sine of A over A, where B is my new angle here, right? That's 24.35. So the sine 24.35 divided by B is equal to, let's see, the sine of 35 divided by 2. And if we solve this for B, B is 2 sine 24.35 divided by the sine of 35, which again, you go to your calculator, this is 1.43. Okay, now, I got a little sloppy on this a little bit with my previous example. Be sure you're answering the question, especially on this one where we came up with so much information, right? I'm going to summarize my results here. Case 1, we had, let's see, we had measure of angle B equals 85.6 degrees. The measure of angle C equals 59.4 degrees, and side B was 3.47. And case 2, we got the measure of angle B was 24.35. The measure of angle C was 120.6, and side B is 1.43. Okay, that's all three cases, right? All three cases for this so-called ambiguous case. Okay, so what's up next? We have one more formula to talk about. It's called the law of cosines. It's nicer. You don't have this ambiguous case. It's an and or. Either you get a solution or you don't get a solution, right? So that's what we're going to talk about in the next lecture.